HTS tries to deliver for the needs of the members, and I think that's evident in a special interest group on Alaska tonight. I want to thank the folks in the North America Committee for putting the evening together, and in particular I want to thank Ian Points. Ian, where are you? Ian, here he is. He invited me back in August to give this talk, so thank you, Ian. Appreciate that. Okay, tonight's talk is kind of a mix of topics about the Cook Inlet at a high level. I don't get down into the details too much, but I'm going to begin by making some brief words of introduction and talk about plate tectonics, exploration history, regional structure and stratigraphy, kind of a broad brush, and a little bit on production history and industry activity, current industry activity, and then I'll follow that with kind of a short discussion on the future potential for the basin. Okay, the state of Alaska, to get everybody oriented, has water on three sides, and Canada to the east. Geographically, we have the Brooks Range to the north, and the North Slope, generally all the big production, the North Slope up here, which is Alaska's largest oil and gas area. The mighty Yukon River is in the middle of Alaska, headed west, drains the major mountain ranges in the Canadian Rockies and the south side of the Brooks Range and the Alaska Range. And then you become kind of mountainous here to the south. This is the Alaska Range and the Alaska Peninsula, which continues on towards the south west to the Aleutian Islands. The area inside the red square is the Cook Inlet, and it's the first area of the state to have commercial oil and gas production. And interestingly, it is the largest center population of Alaska. I think back in the 70s, population of South Central Alaska was like 70,000, 50,000 people roughly, and today it's approaching 800,000 people in South Central Alaska. That includes Anchorage, kind of the Prince William Sound area. So Alaska's done a lot of growing due to their oil and gas success in the last, I'd say, 30 to 50 years. Places you know, Anchorage, located right here, inside the red box, Fairbanks up here in the center of the state, Valdez, which is the southern terminal of the pipeline coming down from Prudhoe Bay. Valdez located right here in the center of Prince William Sound. I wanted to point out a couple things I'll refer to later, and that is this big trench, excuse me, this big change in water depth here in the Gulf of Alaska, just south of Kodiak Island. This is the boundary between the Pacific Plate, okay, plate tectonics, Pacific Plate moving north, and the North American Plate, which is the state of Alaska proper in its position. So you have subduction going on here, and I'm going to discuss that in a minute later, but just keep an eye on that position of that trench. The Cook Inlet is a proven hydrocarbon province. It has an estimated ultimate recovery of oil at 1.4 billion barrels. And from 1958 through 2011, it has produced over 1.3 billion barrels of oil from 5 fields. Very impressive numbers. The estimated ultimate recovery of gas for the basin is 8.5 TCF from 23 producing fields. And the proven reserves remaining for the Cook Inlet in gas are 1.8 TCF. Due to the fact that the Cook Inlet is proximity to the population center of Alaska, and it really, the energy supply to South Central Alaska is really separate from the oil coming down from the North Slope. There's a very high local demand for oil and gas in particular, and gas from the Cook Inlet has fueled this growth for the population of South Central Alaska over the last 50 years. And I'm going to show you some graphics later on that demonstrate how this gas supply is really in decline right now. And it's either two things are going to bring it back to, or will be satisfying supply rather, over the next odd years. It's either going to be success in exploration in the short term to find more reserves and more resource to fuel the Alaskan economy, or they're going to begin to import LNG. And either one of those two trails, the state of Alaska has to make a choice in the short term. When I say short term, I'm talking like 5 years. So we're going to explore that a little more. But the point is, there is a good basin here. It has strong production. It's a proven province, and there are high remaining undiscovered resources here that are a challenge to us as explorers. And the basin itself is underexplored. Okay, exploration folks work in this basin can take inspiration from two people. These two folks on the left is a statue of James Cook, Captain Cook. He is the person whose name the body of water Cook Inlet carries. And in 1777, he came north with a very small crew, rickety boats, I guess by our standards today. He was sailing north for the British Crown, looking for a northwest passage back to Europe. In other words, instead of going all the way back down around South America, he thought there would be a way to the north, and his mission was to find that. And he was a risk taker. He came this way without a map, in the cold, in seasons with treacherous waters, harsh temperatures. People thought he was crazy, and he persisted. And unfortunately, he wasn't successful. There wasn't a northwest passage to be found, but he sailed into Cook Inlet in 1777 as a kind of a world-renowned explorer for his time. And the body of water Turn Again Arm is named for his crew because they had to turn again and go back towards the south. And I'll show you that on a map in a minute. But, James Cook really inspires because he went where no European had gone before and came up into very harsh territory to explore. He was very much an inspiration. And the man on the left is William Seward, who was the Secretary of State in the United States. And he was the one that came up with the idea to purchase Alaska from the Russians, and that was in 1867. And, this effort of his, this passion of his to get a hold of Alaska was very much called Seward's folly. Why would you want to get it, by the cold north? What value would that land have? He was ridiculed by many. He persisted. The purchase of Alaska went through. And when he was asked, he was on in years, and he was asked, what's the greatest accomplishment of your career in your lifetime? He said, it's the purchase of Alaska for the United States of America. And he said, people won't realize that until maybe 1 or 2 generations on. And I just take inspiration from that. So Captain Cook and William Seward. Okay, now I'd like to change gears a little bit and talk about plate tectonics. The Cook Inlet is a 4-arc basin in plate tectonics terminology. And you can see it here on the map on the left. The basin is about 250 miles long. Anchorage is right up here. And from Anchorage to kind of the tip of the Kodiak Island, that distance is equivalent to Dallas to Galveston, roughly. So it's quite a ways. It's a big landmass or area. It's bounded by faults on the west side. The Bruin Bay Fault here in red extends up the west side of the inlet and emerges with the Castle Mountain Fault here across to the northeast. And then there's another fault system on the west, or the east, the Border Ranges Fault, which comes down here from the Kenai Peninsula. It's a boundary between the lowlands and the Chugach terrain, and it comes down here across into Kodiak Island. So this is important because the sediments that actually fill the Cook Inlet are derived from these terrains. You have volcanics on this side here, okay, to the west, and you have metasediments in the Chugach terrain here on the east side. And the story is nicely viewed in kind of three-dimension here on the right. You have the downgoing Pacific plate here being subducted beneath the North American plate, and you have that rising magma coming up, forming the Aleutian volcanic arc. So the sedimentary section that we're targeting inside the Cook Inlet for oil and gas is this little bitty wedge here portrayed inside this yellow square, and it represents the tertiary and Mesozoic sediments that occupy the basin proper. Now, the sediments that are in that wedge are derived from, on the west side, the volcanic arc, okay, which means volcanic source area, volcanic rock fragments, a little bit of a red flag as to reservoir quality. And then on the right side, this trench, or what's called up from the trench, the accretionary wedge. This is represented by the Chugach terrain, and these are all meta-sediments, and we're going to look at a few of those here in a minute. But the point to be made here is that the sediments that we're targeting for oil and gas in the Cook Inlet at depth are very much a mix of rock fragments of various volcanic and meta-sedimentary terrains. The section is tertiary to Mesozoic in age, and it's an active petroleum system, as I've said before. And there's very little in the way of marine incursions into this basin. It's all continental clastics. It's all fluvial, alluvial, and some minor lacustrine deposits, but for the most part, there is no major marine influence. The photograph that you saw on the cover of the HGS Bulletin this month is this one, and it's a great outcrop that I had an opportunity to visit during the AAPG's Pacific Section meeting in Anchorage last May, actually May of 2011. And this particular outcrop is upturned vertical Cretaceous turbidites that are in the accretionary terrain. So these rocks have been scraped up off the seafloor at the trench as the slab is being subducted. They're turned upright. Okay, it's a series of interbedded sand and shale, and just amazing deformation in this section. The outcrop itself, if you happen to be near Anchorage and want to visit it, it's on the Seward Highway, just kind of east of the Border Ranges Fault, and just kind of keep an eye peeled for what's exposed there at the beach. Well, you can see a little bit of detail in this zoom in here. You get like 2-3 inch thick sandstone beds separated by some shale layers that kind of represent a darker color here, and they're pretty discrete, the sands and the shales, but what you end up recognizing with closer inspection is all the sands are vertically fractured, and the fracture density is very high in each of the sands. The fractures terminate inside these sheared shales that really have lost their original depositional fabric, and they've kind of been smeared against the upper bed. So you have these smeared shale units that are not only just deformed and distorted, but some of them actually rolled. The shale is actually rolled as movements taking place along bedding planes. It's a really fabulous outcrop. This is a place where when they said, okay, I think there were like 25 of us, okay, we all need to get back in the bus now. Nobody listened. It was really fascinating to see the detail and have your nose on the rocks. Okay, exploration history. Seeps were recognized along the shores of the Gulf of Alaska as early as 1850 by the Russians. And this map up here on the left shows you kind of red dots and diamonds that point out locations where seeps were actually observed through time. But the ones that affect the Cook Inlet are these three over here. The Aniskin Peninsula, which is located here in this red square right here, it's kind of like a fan-shaped outcrop that extends into the water. There were about 9 wells drilled there. All of them had hydrocarbon shows in the years between 1902 and 1961, which is quite a long time period. But there was an effort there to try to understand better the seeps and produce oil from the seeps, the seep areas themselves, which was unsuccessful. Puali Bay was another area that had drilling go on, particularly around 1904. And that's over here, up against the west side of the inlet. 11 wells were drilled there again. All of those had hydrocarbon shows, but none of them were commercial. There was a small effort near Kenai, which is north of Anchorage, about right up here, in the kind of mid-50s, and really that was not successful either. So 50 years passed, lots of effort, and no commercial oil production or no commercial discoveries in the inlet. Really the biggest hope was the Aniskin Peninsula down here, and that's enlarged over here to the right on this map. And these are Jurassic sediments, and it was here that was documented the outcrops of the Tuxedni Shale, which is the major oil source rock for the Cook Inlet at depth. And the Aniskin Peninsula has had a lot of study. It's had a lot of wells drilled, particularly around here, around Oil Bay in the south side. But again, no commercial success. So in 1957, the effort moved north. And they started to, instead of chase seeps, they started to figure that maybe they should look at drainage anomalies, which the technique of creekology and drainage anomalies have been successful in other parts of the United States, in Wyoming and so forth, where big fields had been discovered. And so in 1957, Atlantic Richfield came up here to the Cook Inlet and drilled their first, or Cook Inlet onshore, and drilled their first well in the Kenai Peninsula, and believe it or not, that was the discovery of Swanson River Field. So that happened in 1957, and it was roughly 90 years after Alaska had been purchased by the Russians. So getting back to the story of Seward, the discovery of oil actually was an impetus to statehood for Alaska, because they realized after so many years that there was mineral potential here, and there was an economic reason. Prior to this discovery of Swanson River, there really wasn't as much of an economic incentive to bring Alaska into the Union. But in 1959, Alaska then joined the states. So that set off a whole flurry of exploration, and here we are all these years later. There's 23 gas fields, 8 oil fields, and over 250 exploratory wells that have been drilled. Swanson River, the initial field, is located right here, kind of oriented north-south here in green. And this chart here to the upper right shows the activity and the successes. How many wells are drilled from 1955 roughly to 2003. And you can see a lot of exploration effort occurred. A number of fields have been discovered, and these are gas fields mainly. And the success ratio in that has varied. But the years from 1955 until 1970 really brought in the highest amount of gas. You know, you had the first 5-year increment, 2.6 TCF. The most successful years were 61 through 65, when 3.5 TCF were discovered. So lots of success here. As many as 85 wells were drilled from 66 to 1970. And it seemed like from there, things sort of dropped off. The numbers got lower once you got past 1970. Well, why is that? There was a remarkable thing that happened. It was called Prudhoe Bay in 1968, which diverted a lot of attention and a lot of spending up to the north part of Alaska. And it was the discovery of Prudhoe Bay that kind of set back the continuing exploration and understanding of the Cook Inlet. This graph here at the bottom is time at the x-axis versus the estimated ultimate recovery in BCF of gas. So the longer the red line in this graph, the larger the field discovery. So you started out shortly after Swanson River with the discovery of Kenai Field here, followed by North Cook Inlet, MacArthur River, and Beluga River gas fields. Those are the main 4 gas-producing fields in the inlet. And then you hit on 1967, and things kind of flatten out. Not a lot of large fields discovered. The discoveries tend to be smaller. So about 95% of the resources in this basin have been found pre-1970. It's a little bit of a kind of a time warp. And it's not only that large fields were not discovered and that drilling sort of, tapered off in order to go to the North Slope, but it was that the thinking in this basin, I think, was slowing down. There wasn't as much seismic acquired. There wasn't the effort put forth to really understand what remaining potential might be there. So, although in the discovery process it's expected that field sizes will get smaller with time as the basin is more understood, in this case there was a complete diversion of effort from working the Cook Inlet, seeing big discoveries happen, and then finding something better somewhere else that really pulled the resources and the effort away. So the big fields that were discovered tended to be on anticlinal trends. They're looking for large structural features, and Cook Inlet certainly has a lot of those. They have a series of on-echelon basin parallel and anticlinal ridges, which are shown here in red. Some of these are kind of parallel to the fault trends of border ranges and Bruin Bay Fault, but as you come farther to the north, they actually diverge to the north more and terminate into the Castle Mountain Fault. So there are a series of anticlinal ridges that are extremely pronounced here, and many of the large fields exist on those ridges. The structures themselves can be three-way closures with a thrust fault, or they can be four-way closures. But the thrusting tends to be with east-dipping high-angle faulting, and again, this is compression because of the intersection between these two plates and the subduction that occurs. So all the fabric that you see is due to the subduction and the tectonic activity, and again, lots of earthquake activity in here as well. This is a regional cross-section of the Cook Inlet. It runs west to east, A prime, so you're cutting through a couple of the major fields. We have Trading Bay Field, MacArthur River, Middle Ground Shoal Field here on kind of a large structural high complex on the west side of the basin. The distance across here is probably 70, 80 miles roughly, so you're very compressed. And the key thing to recognize here is that at this boundary between the blue and the brown, as you come across, or the green and the brown, this is the boundary between the tertiary section and the Mesozoic, or the pre-tertiary. And the majority of the production in the basin comes from the pre-unconformity sediments. So anything above the brown, anything above this major unconformity, pretty well understood. The production is 90% of it comes out of that tertiary section. I just want to point out that unconformities throughout the world are the boundaries where you have a change in rock type, you have potential change in structure, you have a probability of trapping mechanisms for oil and gas. And so it's important as we explore that we really understand the nature of the rocks across the unconformity. So this is a challenge in the Cook Inlet. Very few wells actually penetrate the unconformity in order to understand and map that subcrop. This is a very interpretive cross-section. It's great. It summarizes a lot of the issues, and it's something that we need to build on. This was put together by Peter Heusler in 2000. He published this, and it's actually been it's one of the few regional cross-sections in the basin that's really gotten a lot of play and a lot of discussion and exploration. But it is a challenge to understand what's below this unconformity. It's also a challenge to understand what potential trapping reservoir rocks may exist off structures, away from the main feature of these anticlines, and in a sense of stratigraphic traps and what they may hold. So the future is kind of in understanding stratigraphy, and subunconformity potential. And here's the stratigraphic column. In summary, for the tertiary, the main producing formations are the Sterling, the Beluga, the Tectonic, and the Hemlock, with some minor production of oil out of the West Foreland. And this tertiary system here is a biogenic gas predominantly system. Over here to the right, you can see the percentage of hydrocarbon production by product that comes out of each formation. So the Sterling Formation, for example, produces about 65% of the gas that comes out of the basin. The Beluga produces about 10%, and the Upper Tectonic about 25%. The second active petroleum system is the Tuxedni shale source that's expelling oil into reservoir surroundings. This is lower Tectonic hemlock commingled, and then the hemlock conglomerate. The hemlock is the best oil producing reservoir in the basin. It's producing about 60% of the oil that's been produced. So interestingly, you think, well, why is the gas shallow and why is the oil deep? And it's because this interval here at the top in the tertiary has a lot of interbedded coals, and it's those coals that are generating gas in a biogenic system. And as you go deeper in the basin, you have the Tuxedni shale, which is the oil source, and that's expelling oil, and that oil is migrating to however and wherever it migrates, mainly into these lower tertiary section reservoirs in the Tectonic and Hemlock. Now, this is a diagram that's kind of an attempt to serve as a type log, and it's probably my favorite diagram in the whole talk tonight. I want to spend a little time on it, but what it is a 15-well display of the shale curve. And what it does is it shows you the differences in a V shale sense or a shale volume sense of the Sterling, the Beluga, and the Tectonic and the Hemlock reservoirs. And as I said earlier, this is a continental clastic environment. We have fluvial and alluvial deposition happening here through time. This section is all clastic, so no big limestone marker beds in here, no marine section, no, nothing you can really put your foot on in terms of a top and say, this is the so-and-so. Because everything is very gradational. It's very discontinuous. The sands come and go. There is not a regional marker bed, per se, that you can carry from the northern part of the basin down to the south and speak with confidence that you've got a correlation that is working. So what this figure does is it zooms out for you. We go from the surface down to 10,000 feet subsea, okay? We've taken all these V-shell curves and we've zoomed them down or zoom them out so that we can really look at patterns. We begin to look at packages and say, okay, where do the package changes exist? So as you can see in the Sterling part up here at the top, there's a lot of white. And a lot of white in this display means sandy. The more gray you have, or rather kind of light brown, you pick up more shale, more siltstone, more fine-grained material. It's very sandy at the top here in the Sterling, and then you begin to lose some of that sand as you get down into the Beluga. It's still good reservoir rock, it still works, but you're losing sand percentage. Then you come down into the Beluga, and or at the Beluga-Tectonic boundary, and what happens? You begin to pick up coals. Okay, and these are thin coals, 20, 30, maybe 40 foot thick, and they're interbedded with sands of comparable thickness. And they're interbedded with siltstones of comparable thickness. And you can see in these white patches again, these are the sands, more porous units. And as you come down to the bottom of the Tectonic, you got lots more coals. You get 5,000 to 6,000 feet of coaly sand section. You come down into the Hemlock, which is this green marker correlation down here. And the marker between the Tectonic and the Hemlock is you begin to pick up coarser grain material and conglomerates, which are also productive. So the nice thing about this diagram is it captures, you know, the general trends with depth of the tertiary reservoirs. The interbedded nature, the coaliness, the fact that your sand abundance decreases with depth, the, you know, lateral discontinuous nature of the sands, and also the fact that you have very complex rock properties. You know, remember I said earlier you've got volcanics feeding into the sedimentary basin. At one side is a source area, and the other side you have metasediments. So what's happening here is you get a commingle of these mineralogies that are making up your framework grades for the basin. So that's happening in you know, Tectonic, beluga, hemlock sands, and conglomerates. So the challenge for us as explorers, to take it a step farther, is that if someone gives you a log and they say, okay, here's a log, where's the reservoir? You know, and then you have to take it a step farther and say, okay, of what you've defined as reservoir rock, where's the pay? And why do you think that's the pay? And kind of go through. But it's a very tedious sort of path to come to an interpretation in this section, because mineralogically the variability is very high, okay? The sands are very discontinuous, and the influence of, I would say, uncertainty and correlation is very challenging. So this, in a nutshell, is the challenge that we face in exploring in the Cook Inlet. And perhaps it's why they decided to go to the North Slope, where there are nice, clean marine sands of hundreds of feet thick and high porosity and permeability. Here's an example of a reservoir exposure of the Sterling Formation. This is a 25-foot thick sand channel exposed near Clam Gulch, which is in the southern side of the inlet, right on the beach. So you can see this erosional surface here, nicely defined, the black dotted line, cutting into a section of interbedded coals and siltstone. Okay, the map on the left is a map of the exploration wells drilled in the basin. Not very densely populated with exploration wells. Lots of areas in the offshore where these anticlinal trends do continue that have not been drilled. And lots of open areas in the offshore, down here off the Kenai Peninsula and over here closer to Anchorage, that really haven't been drilled and tested. Just summarizing the effort over time, from 1950 through 1980s or kind of mid-90s, the main charge for companies in here was looking for oil. They wanted to find oil. That was the desirable product of exploration. They drilled these exploratory wells. Where they were successful, they'd appraise them, and if they were economic, they'd develop them into fields. But along the way, there were dry holes, and there were wells that were drilled that were really economic failures. They may have had hydrocarbons, but they couldn't really make it into the economic realm of production. So around about 1980s, 1990s through to today, these wells that were dry holes in the early days are reevaluated. You know, a well that was a dry hole would get re-drilled if it had gas shows in it, because they weren't looking for gas in the early days. They were looking for oil. So the value of gas increasing from, you know, the old days into, you know, times forward from the 80s on, the gas had value, and they tried to capitalize on understanding the dry holes that had been drilled in the basin. So what was sub-economic then could turn into a discovery in today's environment. Okay, a brief look at oil and gas production history through the basin, through time. This is a million barrel per day of oil production, 1950 all the way through 2011. And you can see this big ramp up of oil production. The maximum was reached in 1970. Production was about 225 million barrels per day, dominated by oil coming out of the MacArthur River field, which is this dark purple. Other fields producing oil were Trading Bay, Swanson River, and these really were the dominant contributors to oil production in the basin. And then around about 1970 or so, this ramp started happening, and we've really been in decline ever since. So this decline of oil production in the basin has been very significant, and now it's down to less than 20,000 barrels a day. On the gas side, this is the Cook Inlet annual average daily gas production in MMCF a day. You can see it ramped up here. The biggest contributor, it got online in the early 60s, is the Kenai field. This is in the dark red, and it's been the main contributor to gas. You've had other contributors, Beluga River, North Cook Inlet fields also, but the point to be made here is that the Cook Inlet is declining seriously in oil production. Okay, it's at an all-time low in oil production, and it is in rapid decline of gas production. And this has really grabbed the attention of the state of Alaska, and they're trying to arrest this, turn it around, do what they can, because the population is dependent for residential heating, which is very important in Alaska due to the climate. It's very important for residential heating and industry. So looking at these numbers another way, we're looking at field sizes. On the left is the gas produced by field. There's 4 fields that have over a TCF of cumulative gas production. And I find it hard to believe that in a basin this size that is so huge, there can only be 4 fields with those kind of numbers. So based on this alone, for me, I think there's got to be more gas in the structures out there that are yet to be drilled. There are smaller gas fields that have been found. These are shown up here in this pie wedge to the top. Very small accumulations, but they're really divided in small small structural features or off the flanks of some of the larger features. But I think there's a very high probability that there are existing gas fields in the basin that are greater than a TCF. To the right, this is cumulative oil produced by field. The oil in the Cook Inlet production is dominated by the McArthur River fields. Almost half the oil comes out of one field in the basin, and that's followed by the Swanson River, the Middle Ground Shoal, Granite Point, and Trading Bay, and these kind of make up, those 4 fields make up the other half of oil production in the basin. So this is a summary of industry activity by lease sale history. So I'm taking you from 1959 over here on the lower left all the way across to the year 2011. And you can see there's a lot of jumping around. There's not a lot of pattern to the lease sale activity. What you do notice, though, is the spikiness. Acreage leased, you've got a couple of giant spikes here, and I think that's the most significant of the 2 variables here. In 2011, we had more acreage leased in the Cook Inlet than in the last 10 years, 1993, back in the 90s and 80s. But this can be attributed to the leasing of Apache. They came in, they have about 800,000 acres in the Cook Inlet, and that's since 2010. So they've come in, taken a look at the basin, and been very bullish in their approach towards exploration. The total high bids, which is the purple bar, you can see that jumps around. This one, which is extremely high, came in after a very competitive lease sale after a discovery called Sunfish in 1992, and I think that's a function of what value companies put on the acreage. So that was really the most expensive, the highest dollar figure lease round or lease sale that occurred. But in the intervening time, you have very low bids, very low activity in these lease sales, and a lot of variability in the number of acres leased per sale. Okay, this is a diagram I felt compelled to include, and it's the Kenai National Wildlife Refuge, which has off limits to exploration a significant portion of the basin due to federal regulations. And this is probably accounts for about 25% roughly of the Kenai or the Cook Inlet basin in terms of its prospectivity. This red line divides the Chugach terrain to the east from the prospective Kenai onshore basin portion to the west. So it's been shown that from potential fields data and so forth that there are features in here that look attractive, but because of the fact that this is off limits, provides restrictions to the industry as to whether or not we can evaluate those features. Nonetheless, there's been significant amount of study done on what the remaining potential is in this basin, and there's two reports that I would like to cite. One of them was done by the state of Alaska. It's called the South Central Alaska Natural Gas Study. It was done in May of 2004. They were really looking at how much gas, does this group think, and this is a report done for the state, how much gas they really think is left in the basin. And they say that a total Cook Inlet resource endowment of 25 to 30 TCF of original gas in place is proposed. So there's a significant higher amount of gas in the basin remaining than has already been discovered, according to this study. And then most recently, in 2011, the U.S. Geological Survey did an assessment of what is a technically recoverable resources. And they came up with some really huge numbers. The mean undiscovered volumes of oil, 600 million barrels. I mean, that's another McArthur River field. That's a lot of oil. And 19 TCF of gas, along with 46 million barrels of natural gas liquids. And this was really a very bullish study. It was done very carefully. Rick Stanley in Menlo Park was the one that led this work, and he really did a very careful assessment with a lot of involvement from the experts working this basin for a long time. So the Cook Inlet does have a lot of remaining potential. It's just a matter of getting to it, of getting the data necessary to assess what is there in a structural and stratigraphic sense, and shooting seismic so they can really see the interval you want to see that will open up some new plays and push the basin to the next level. So in summary, I'd like to say that there's a very strong market demand for energy in South Central Alaska, particularly gas. Recent news, there's some new players in the basin. Apache is a big one. Hillcorp came in recently buying the assets of Chevron and Marathon. And a very bullish company, Buccaneer. I saw several Buccaneer folks in the audience. Nordac, another company, and also Fury. The major oil companies are leaving, and the independents are entering the Cook Inlet in a big way. And I think it's the independent companies that are going to have the fresh ideas and challenge the status quo a little more than some of the companies that have held these fields and acreage and assets for a long time. So to develop new play types and take this basin to the next level, we need creative explorers, geoscientists that are going to try some new ideas and push some new styles of thinking and interpreting the geology in this basin. And more drilling is necessary, access to promising acreage, and a reevaluation of the data that exists, as well as acquiring new data. And particularly seismic data, new seismic is needed to get to some of these important issues that we have yet to understand. So with that, I'd like to thank you very much for coming. I'm going to conclude with a photograph provided by Chevron of the monopod, which is Trading Bay Field offshore up against the backdrop of the volcanics. So hopefully we will find more oil and gas in the Cook Inlet. And thank you very much for coming. So I think Alaska is an oil and gas friendly place. They realize that a lot of their state revenue is dominated by oil and gas revenue. Oil and gas and mining are the really two big resource plays in the state. The Cook Inlet is has kind of one set of rules onshore versus offshore, and it's a matter of getting permits to do what you need to do. I know there's permits really required everywhere you go in oil and gas, but there are a lot of particularly sensitive wildlife areas and areas that are protected. There's beluga whale habitat in the Cook Inlet and the offshore. So there's issues around wanting to not have oil and gas activities during certain times of the year when the whales are active there. And I think it's just a general sense of stewardship that the state of Alaska wants to maintain for the wildlife and the environment, particularly because they have so many people that enjoy the outdoors and enjoy the wildlife, and they want to keep that compatibility working. But I think overall, it's a very positive environment for oil and gas in the inlet.
A couple of questions, Denise. First of all, is it state waters or federal waters or both?
It's state waters until you get south of Seldovia, and then it becomes Outer Continental Shelf, which is administered by the federal government.
Okay.
If I can take you back a couple slides, you can. Okay, OCS, there it is. Outer Continental Shelf. Once you cross that brown line in the offshore, you're in federal waters.
Second question, economic. What's the gas price up there?
I'm sure someone in the audience could answer that better than me.
$6 to $14.
Okay. 470?
That's at the wellhead? Or at the gathering point?
Contracts, future contracts right now are already $7 above.
$7 an hour. Okay.
Cool.
And we sold some last winter well above that.
You repeat the statement for the rest of us.
Future contracts are $7 and above, and you sold last year for higher? Okay.
But last winter,
Last winter.
the spot market was twice that.
Spot market was twice that. Last winter. Okay. Yeah, Charles.
Second order.
All right, so there's a lot of different types of traps. So just ballpark, how much of it is stratigraphic? Like, is it just a little bit been touched that's stratigraphic, or is it mostly structural?
Well, I'll put it like this. Most of the field, 99% of the fields out here are structural, from what I know. Now, I've not looked at data from every field by any means, but I would just say that throughout the 50s and 60s, when all these initial features were drilled, they were all structural. And to quote someone I heard recently tell me about a potential well that might be a discovery, they were saying, and it could be a stratigraphic component that it has. So what I'm saying is stratigraphic traps have not been deliberately explored for in this basin. That's my impression. I mean, there can be off-structure stratigraphy that's productive, but what you have to do is get better seismic in order to determine that. Donna.
What are the average porosities and permeabilities?
Well, the best porosity and permeability is in the Sterling, which is the shallowest, most sand-rich section, and it probably gets as high as 25-30%. And it goes down from there. There's a general tendency for reservoir quality and porosity and permeability to decrease with depth, which is part of the reason why there has been very little exploration below the unconformity into the pre-tertiary. But the way I look at that as an explorer is I think, well, if you have an angular relationship between the lower section, the section below the unconformity, then you're not going to hit the same formation everywhere you drill in a pre-tertiary sense. So you need to kind of come up with a model or a concept as to where you think the best pre-tertiary rocks live, essentially, and then carry out an exploration program to test that concept.
Yes?
If I'm not
not mistaken, the two studies you mentioned discuss the possibility to have unconventional reservoirs in Cook Inlet. And due to the harshness of the terrain, what role do you think those will play in the future?
Unconventional? That's a great question, and you know there are outcrops of that Jurassic Tuxedni shale, which could be a potential shale play onshore, and that's the area that I talked about initially in the talk where you have a lot of seeps. That's the place where they had very first made the effort to find commercial oil and gas. I think there's a place for that down the road. I'm not sure that's today, but it's certainly worth exploring. And you know, to get to an understanding of that potential, what you'd have to do is go out in the field, sample the shale, and really look at its total organic carbon, looking at, you know, what exactly is the makeup of that shale and what's its thermal maturity. Because if you could put a rig on that, you know, in Outcrop and extract gas out of it, I mean, you could probably do something with that. Or if it was not too deep and not too shallow, I mean, you'd have to have a person work that is very savvy about other shale plays and how they've worked and how they've been developed. Because I think this area is unique. There's limited access. There's getting a rig to the place you need to get it to, and so forth. So it's challenging. Yeah, Steve.
Do you see abnormal pressure anywhere in the basin?
I'm really not the person to ask about that. I think it probably varies. And the reason I say that is because the sands that you're targeting that are productive are compartmentalized in places. You have a lot of pressure compartments. You have sands that are discontinuous and unconnected. So as you drill down through these layers, you're subject to pressure variability. What the numbers are exactly on that, I don't know. Anything else?
One
Yep.
question by me.
Yep.
What is your main seal in that basin? Do you have one? Since it's continental?
Well, that's a good question. It's the siltstones that are encasing the shales. It's the lower permeability units that are stacked in the inner beds between the sandstones.
But you don't have a pervasive seal over the basin. It's just very local seals. It depends on the stratigraphic history of that particular area.
That's the way I understand it, yeah.
No real good seals.
No real good regional seals.
Well, you're getting them
There's a
normal
bunch
fresh.
of good
You're getting them normal
fish,
fresh.
but not-
Okay. Oh, one more. Mike.
Has there been much or any horizontal drilling in some of these compartmentalized fields?
You know, that's a good point. There's been horizontal drilling to the extent that they put a rig on the beach or near shore, near the shoreline, and try to drill directionally to a structure offshore. And that's been
Drilling, just directional drilling.
directional drilling, right. But there's a space problem with that because there's a little bit of a desire to get, you know, farther and deeper, and some of the rigs onshore can't get exactly to where they want to get to. But it's a way to work around the issue of not having a jackup rig or something that can stand in shallow water in order to drill the features you want to drill. So Marathon's been very successful working in Nilchik, Kasselov, you know, some of the nearshore fields south of the Kenai gas field. And to me, that was a really innovative way to approach getting at the resource. But recently, in the last year, there have been 2 jackup rigs arrive in the Cook Inlet. One is operated by Buccaneer. They're going to be drilling Cosmo, hopefully soon, and which is Cosmopolitan Field in the offshore of the Kenai Peninsula. And the other one is Fury, has a jackup rig that they're drilling kitchen lights with right now. So I think our access to the offshore, our access to these larger structures along the anticlinal trends I talked about is going to increase from an industry standpoint. Yep.
There are horizontal wells being fractured in Cook Inlet successfully, yes.
Okay, there are horizontal wells being fracking what, unconventional type sands or
Beluga targets.
beluga targets? Okay,
Hitting them, fracking them.
very good.
Uh,
Successful?
One of the major companies is keeping the field alive that way.
Very good.
We didn't hear the answer to success.
There is there is a major company keeping a field alive that way until, yes? I can't hear you too well. Yeah, let me get my mouse working here. These that you see oriented, kind of on trend, these over here, these over here, they're all targeting an anticlinal closure of some kind. Now, these anticlinal closures come down into this area here, but why they were never drilled down in this area, and this is a big vacancy of drilling, I don't know. Over here, the same thing.
No 3D on that.
That's one
Yeah.
of the reasons.
Yeah.
And
Exactly.
very little good quality too.
Yeah, and you know, the thing about this hiatus that happened after Prudhoe Bay is it's not just the fact that they weren't putting holes in the ground after 1968. It's the fact that they weren't gathering seismic, they weren't doing data, you know, they weren't acquiring data.
They were just producing.
You know, it was just a productive zone or a productive effort from the companies that had existing fields. And what happened was there was kind of a big slowdown in the effort to understand this basin. So I look at it as what I call postage stamp analysis that was happening then. You had a field, they'd shoot 3D around the field and not really give much attention to the broader regional picture of the basin because that really wasn't what they were wanting to do economically. But, you know, when you and I come in and we're in a new ventures group or we're in a position where our boss says, okay, where's the next place we need to look at in the Cook Inlet? You know, we're starved for a regional understanding of the basin and say, okay, here's where we think the next big field might be, or over here. You know, because we don't have this regional perspective, it's frustrating. And I look at the Cook Inlet and I compare it to another basin I worked years ago, the North Sea. Well, the North Sea is got so many regional seismic lines across it, from so many different vintages and so many different efforts and so many different companies and consortiums. And I mean, the effort to understand the North Sea regionally, it just blows your mind how much money has been spent out there. And the Cook Inlet, no one's done that yet. So I'll digress before we adjourn and just tell you that I started working this basin in 2006, and I was working with Robert Pledger and Craig, and we were trying to put together an understanding of the basin. And I'd go to data pages in APG, and I would type in Cook Inlet and try to pull up some literature, and it was like 3 things would come up, and I thought, man, this data page is just broken. The search engine's, turned off tonight. And I was very frustrated by the fact that this was a major basin in North America, and there really wasn't that much published on it. So fast forward a couple of years, I made a proposal. I was, thinking, I like this basin. I've invested many years in trying to understand it, and I don't just walk away and start another project somewhere in the world. I want to understand this basin. And so I felt like there was a need here, and I teamed up with a colleague of mine in Anchorage named David Height. Some of you might know David. And he and I put together a proposal to AAPG and said we would like to see AAPG publish a memoir called Oil and Gas Fields of the Cook Inlet. And here's our wish list. Here's what we think should be in it. And we're willing, if you guys want to fund it, we're willing to be co-editors of this volume. And so AAPG loved it. And they were really psyched about it and said, yeah, let's do it. And so for the last 3 years, David and I have been working on this memoir. And we're hoping it comes out next year. We've got 10 chapters. We've got a lot of the fields that you've seen tonight on the maps. They've been described. They've been detailed as to what makes them tick. What is it about the reservoir, the structure, what is it that makes this field? And we've been very delighted to have contributions from all the major operators. Chevron, Marathon, the state of Alaska. We've had contributions and cooperations from really many folks, ConocoPhillips, it's really been wonderful, and we're hoping to see it come out next year. So if you're a fan of the Cook Inlet and you want more, stay tuned. We're hoping that this will come out next year sometime, and it'll be for sale in the APG bookstore. So, thank you very much.